is what's important. Also, quick important aside note is I just tested the audio to make sure that the audio works on the video. All right, everything's cool. That was cheeky. I'm sorry. So, trust me, I've definitely done it several times. Either way, yeah, there has to be some way Chris can improve, and I'm glad that's the only thing I have found. Cool. So these two snippets are different, right? You have something like object.method, and then you have var method is equal to object.method, and then notice how in this second one, this is simply assigning a variable method the function definition, and then it invokes. So 1 and 2 are different. I've talked about this before. Oh, I'm sorry. I've talked about that example before. Oof. Sketch. And here's what I mean by the example I was mentioning earlier. All right? Talk about like the function keyword where I can have a cool function. Boop, boop. And all it does is console log, right? Cool, man. Cool. And that's all it does. And then we also talked about the fact that I can do something like const mega cool. Like, you ever seen the meme? The cooler Daniel? No? It's equal to a function. And I said that you can do either one. Do you remember this? Do you remember that example? Oh man, this is going to get dicey. All right, console log. And basically, I think he just had sunglasses. Sunglasses? Oh yeah. The cooler Daniel. We could look up that meme later, but I don't have time. The idea is that cool function is just a function, and the cooler Daniel also is a variable that is storing a function definition. So far, how are we feeling just about the way that they're being declared at the moment? It is not the full length of what's actually happening. All I want to know is how are we feeling about the differences between these two and how they are written. One is just the actual function keyword, and the other one is literally a variable that is storing the function. One of the main differences that I talked about earlier was how JavaScript reads and executes your code. And in that first read-through, as it's storing everything in memory, the fact that it will read this as a variable, what will happen to the second half of the assignment operator? Yeah, it's sort of left alone. It is initially undefined. So the first thing that you've already learned about the difference between these two is, had I used var, all right, both of these would hoist. Because I didn't, which one will hoist? The cool function, right? And not the cooler Daniel because of how JavaScript will read and run your code. So far, so good on that. All right, oof, nice. We will get back to Dan Abramov's example, and let's continue. Okay. Let's review how self is in Ruby, because if you learn self, it'll get you like 30, maybe 40% there in terms of understanding this. I'm not going to do that. I tried it. Didn't like it. It's going to get you partially the way there, but you have to understand that the this keyword is different. And so the first thing I want to talk about is, let's talk about self. Man, good old Ruby. Haven't written this in a long time, huh? Looks different. So we just have an adder accessor, and we have initialize. All this is saying is if I make a person.new passing in something, it will pass in that argument and assign it to be the instance variable, and therefore Andy has an attribute of .name. If I say self.saySomething, what type of method is this? An instance or a class method? Class. So it's important that where I write self is what self will be in Ruby. Where I write it is what it will be. So where it is defined and declared is what it will be in Ruby. In JavaScript, the this keyword, it is important both where you write it and when you execute. It will determine it differently. Just that sentence alone. Any questions on how Ruby understands self? Okay. I don't like using those weird phrases, but yeah, we will be unpacking it very soon. We can finish that offline. Let's dive deeper. Let's get granular. I like that. I love the synergy of this dynamic of the class. Self is not this, right? Let's talk about the this keyword. What does the word this mean as you're using it in English?
Specifically, what I was talking about in the last sentence. Or
correct. It is context dependent. Whenever we talk about self, like myself, I'm talking about who at that given moment. And when I refer to myself at any given point, or I say self, it's always pointing to the same person. I don't want to say thing, right? People are not objects, right? That being said, if I said something like, man, this food is delicious, because I ate like a really good burger yesterday, and then I said, this commute stinks because the 4 and 5 trains had delays this morning. When I said the word this, did I refer to the same thing or different things? Right. Literally, words mean things. So self, right, will imply certain things, and the this keyword will take on the meaning and definition at the time that I said it. And so the context of what I refer to this as changes whenever I say it. So this class is great. And then in a few weeks, when I say this classroom is dark, I'm talking about different things. All right, you like that? That was sneaky. I don't play favorites. Does that make sense? So even the word this and self are different, and that is why we should not equate them. So, moving on. There are 4 main rules that govern how this is determined. And so Andrew, like a former instructor, Andrew, always like thought of this as clickbait. He's like, 4 simple tricks to learning this. Developers hate them. I always thought it was really funny. We will start with rule number 3. I don't know why that's funny, but it always is. Great. And it's because in rule number 3, it makes the most sense. It's something that you're familiar with. And that is if I have a object, dog, and there are 2 attributes, name and another key that points to a function as its value. And it simply returns this. So if I were to do dog and I do dog.name, what should I get? Winfield. If I do dog.what is this, what will it do? It will simply invoke this function. And it returns the this keyword. This, in the context of dog.what is this, will be the dog. Example number 3 is what you imagine self to be in Ruby. Are there any questions on that sentence? In example number 3, this looks like self in Ruby.
If you did return this name, would it be still?
Yeah. If I did this dot name, I should receive Winfield. Who here feels comfortable with just rule number 3 as I've explained it for the this keyword? All right, great. Let's talk about rule number one, sorry. You've done in your discussion questions already the constructor function, learned a little bit about object-oriented JavaScript and how the this keyword plays into that. So let's take a look. I have a function called person. I've capitalized the P here. If I capitalize the first letter of a function, I'm indicating to the user, the developer, someone else that's looking at my code base that this is a constructor function. There is no real difference between a function and a constructor function except the fact in the way that I'm going to use it. Therefore, in order to let somebody else know, I'm just going to capitalize the first letter. I literally have two things in here. I pass it in a name favorite color, and I pass it in this.name, this.favorite color, and I'm pulling it from the attributes, the parameters that I've passed in. Example number one, it looked like a Ruby, right? If I do Andy, the only real difference is in order to do a new instance of an object, of like a template, so to speak, it's new and then the constructor function versus how it is in Ruby, which is person.new. So just a little bit janky, a little bit opposite. It's the way the language is written. Please don't hurt me. If I create this and I do Andy, I should receive this person object with these attributes. So let's do it. If I do this, bloop, bloop, bloop. If I take the example given and I do Andy, I get person. Basically, it's this person, and I have attributes, name and favorite color. So I can do Andy dot, what is Andy dot name? And what is Andy dot favorite color? So this also looks like a Ruby so far. Yeah.
When you use a constructor function, is there a difference between using the keyword function versus the keyword class?
Yes. There's a huge difference between the keyword function and the keyword class, yes. We will get into that as we do object-oriented JavaScript in part 2 of this lecture. Yeah, good. All right, so any questions on like what this is doing and what it's referring to as it is binded inside of this function, this constructor function? Okay. All right, here's where it starts to get real dicey. Rule number 4. This, without any sort of context, what is known as a baseless function, will be the window object if you're writing browser-side code. If you're writing Node, so you have like JavaScript that's run in the browser, then you have Node.js. Node.js is the global object. Here we have the window object. What I mean by that is we have window, and we have document. We've talked about these things. Then we have this. This points to the window. Literally just blankets to the window. This is in the global execution context. When JavaScript first runs, this points to the window object. If you're using something called strict mode, it is undefined. And that's okay. We won't really get into that. I don't have time to dive into it, but we could talk about that after lecture. So we have the window object, so we can do this.fetch. Because the window object is what actually has the fetch API. Look at all these like cool functions on this, right? We've seen this before? Are there any questions on what this is when it's first set and it's not inside a function, it's not inside anything? Okay. So that means that if I were to do the function keyword and say, what is this? Boop, 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 and I console log the this keyword. If I execute what is this, what will it be? The window, it should be the window, right? What is this? Oops.
question?
It should be return. I should return this. Embarrassing. There's no. All right, it's the window. Sorry. Got into the console log habit. All right, so this is known as like a baseless function. This is going to come into play later. Now let's dive into this weirdness over here. Blah blah blah. All right. Let's dive into this weirdness. Cool. There are 3 ways to kind of set what this is. So as you've seen, by default, this is the window object. All right. You've also seen that once I'm inside of an object, this keyword will change. So inside the dog object, when I'm running dog.whatisthis, it will change. It changes to dog once I'm inside the dog object.
Yeah.
All right, cool. So I can actually force what this keyword is by using one of 3 methods, and that is apply, call, and bind. Actually, it's bind, call, and apply. That's usually the order that they're set in. So let me explain them to you. I have person 1 named Andy, person 2 named John, person 3 named Gary. I have a function called sayName, and all it does is it takes in a location and it takes in a time. All I'm going to do is return a sentence that says this.name, which has not yet really been defined, says hello from location and time, which it's going to be pulling from when I invoke the function. Are there any questions on just what I'm trying to do here? So, what will happen if I invoke sayName with New York and now o'clock? What is this dot name? Right, this dot name is just a blank space. Because what is this? The window. And what is this dot name? Actually, for whatever reason, the window object has a default of an empty string. So if I said this dot name, yeah, it's very weird. If I said this dot name is equal to your boy, and I were to run sayName again, what should I get? Because this was the window object. Now I can force what this keyword is. I can change the context of this by using either bind, call, or apply. So here are kind of the main differences. Let's talk about call, and we'll talk about apply. Let's take a look at them. Call does 2 things. It invokes and will change the context of what this is. It will bind that function. So sayName.call, if I pass in something and then the 2 arguments, it will change this keyword to person 1. How many arguments does sayName take?
2.
And how many is call taking? So that means that if I use call, I need to add in an extra argument. And that first argument is whatever I'm going to bind this keyword to. So if I pass in person 1, and I see person 1 is here, what is this? It is the object. It is the person 1 object. The whole curly braces. So, what is person 1, which is now this, dot name? So, if I put this dot name here, and I did call, and I passed in person 1, the object, I should see Andy says hello from Morocco at 3. Because I've changed what this keyword is. So call will actually invoke and change this keyword. It will invoke it immediately. Call invokes immediately. How many arguments do you see here? 3. Now, when it comes to apply, without looking at anything else, how many arguments does apply take? 2. So what the difference between call and apply is call will ask for each one of the original arguments, and apply will ask for all of the arguments that you want in an array. That's the only difference. Apply will also invoke. Are there questions on call and apply? All I'm doing is, if I use call and apply, I invoke immediately, and I get to change how I set the this keyword. Now let's talk about bind. This is the only one that you will use and need to understand. I taught you call and apply because it's important for metaprogramming, and it falls under the umbrella of this. You will only really need call and apply if you are writing code for somebody else. What that means is, when you write a gem, or you download a package, or you use like npm install or whatever, right? That person that wrote the code, that wrote the gem, that wrote this package, who do they write it for?
Everyone.
They wrote it for like anyone to download. And that means that if you wrote it for someone else to download, you have to make it so that it works in different context executions. And so this is when call and apply might be useful. So that's more metaprogramming. When I write programs that help other people program, right? So I want to introduce the idea to you and level you up as a skill. But if you do not really remember much about call and apply, I'm going to be okay. And you'll be okay, I promise. Now, bind is different. Bind is very important because you will sometimes want to change what the this keyword is, but you won't always want to invoke it immediately. So bind will set what the this is and create a new function. It doesn't invoke. So what I need to do is actually set it to a variable that I can then invoke later. What that means is if I do say name.bind and I pass in, oh boy Gary, did this invoke? No. So bound person 3 takes in how many arguments? Just a regular 2. It's just a regular function, except the this keyword changed to Gary. So now if I log this, it's no longer going to pull from the window, but it will pull from the person 3 object. That was an intense reaction. I almost want people to start saying jinkies now. So who feels comfortable between the difference of bound person 3 and just invoking the function? Invoking bound person 3 and invoking say name. The differences. Yes, no?
Yes.
You could say no. Please feel free, comfortable to say no. This is important. You don't have to know why you don't understand. I just need to know whether or not you do or you don't. Because if you don't, I will try to explain it. If you do, then I can move on. There's a lot of material. So I would like you to be comfortable with this. With that. Oh, God. Question or you're good?
Question. So for the dot bind, in order to validate using, you need to first set it equal to a new constant, and then call the constant that you just created with the arguments you made? The arguments that were originally applied? Or is...
Yes. What bind will do is it will create a copy of the original function and simply change this keyword to whatever you pass it in. So if I did say name.bind and I had another object, I can pass it in that as well, and that will be a different function.
So setting it equal to something else. It's a way
Yeah.
to separate.
Here's a good way to do it, and the only good way to do it is to honestly to test. So I have bound person 3. So far, so good. I can do const another person, and that is just going to be an object with the name of Liz. If I did say name.bind and I passed in another person, what should I get back? It's a little hint there.
A function.
That's right. It's just the function. It looks the same, except now this keyword refers to another person, and that's it. Here's the weird thing, though. How do I ever get access to this?
That's what I
Store it.
You just have to store it into a variable so you have access to it. Otherwise, you have to do this dirty move over here. Yeah, then you have to. The location is here and now. So unless I store it, I lose it forever. Yeah, it's kind of like if I was like, hey, 7 plus 4. How can I reference 11 again? I can't. You know, it's just an expression.
Could you call bound person 3 and in the bananas put a new name like another person and it would work still?
So the question is, bound person 3, you want me to pass in another person?
Yeah.
Well, remember, bound person 3 is a copy of say name that takes in 2 arguments. So
But when you wrote it, you're saying that it's like,
it is literally a copy of say name, and all I'm doing is changing what the this keyword is.
yeah. But you can't change that argument.
It's a constant, so you don't have to do that.
I can't do anything. Yeah, it's a const.
But if it was let,
If it was let,
We could rewrite like say name.line or something.
if it was let, what would let do for me?
why you didn't change?
I can reassign what the variable is. I cannot redeclare it. I don't know why I would ever reassign a function to do something else. Like I would never write like var function and then like write a function, and then I would never put var this is a function and then have it equal to like function. God, this is annoying. And then do this is a function equal to 7. Like I would never do that. So once I've basically set it to a function, I've set it to a function for a reason. I'm always going to use it as a function. So const would be the right move. All right. Any questions on just understanding bind, call, and apply? Not necessarily the practical application of them right now, but just what they are and how they work. You can always MDN them. They're powerful. All right. This is important. I want to talk about the arrow function. So I have a const called this arrow. And all it is it's an object with a key of say this. It returns this. There's no real difference between what I wrote earlier with the function keyword and the arrow function. So when I do this arrow dot say this and it returns this, what should it be? A window. There's no real difference right now. Okay. So there's a couple things about the arrow function that I want to clear up. If it's one line, I do not need the curly brackets. Cool? And it will implicitly return, meaning I don't have to write the keyword return either. All right, cool. So if I run sample arrow and it simply returns this, it should be what? Window. So far, so good. Nothing wild. Now, I had a lot of fun like doing a lot of this dumb stuff. So let's take a look at this. You're right. Let's take a look at the example I'm typing and finish typing right now. I have Angry Chef. Inside of Angry Chef, what should this be? So if I did Angry Chef dot chef name, I should get, where's the lamb sauce, right? Chef Gordon Ramsay. If I did, however, cook food, which is just a function, What should I see
The function.
if I invoke it? I really should take off preview.
Is cooking.
Get undefined. Now let's do this. Ready? If I were to do happy chef, and instead of the arrow, I wrote function, and I took in food item. Cool. If I did happy chef dot cook food, and I invoke it, what should I do? What should I see? Actually, let me invoke it with the food item. Lamb. So remember, angry chef dot cook food with chicken is undefined as cooking chicken. Cook food is lamb. What is the only difference between angry chef and happy chef inside cook food?
Arrow function.
The arrow function. So, without understanding it, what can you tell me about the arrow function and the function keyword as it handles the this keyword?
It is different.
That is correct. It is different. Yes, check. Check on that. I need that to be clear. The arrow function will handle the this keyword differently.
Why though?
I'll talk about that in object-oriented JavaScript as to why.
It's in the labs for arrow functions a long time ago.
Which you've understood?
No.
Oh. I was hoping for a yes, but
Well, I know this.
So, in any chef, what is this referring to then? If it's undefined. Is it still the window or is it something else?
it is going to be the window. So the function keyword, what it will do is it will create its own context execution, and it will set the this keyword. The arrow function does not create its own context execution, and it does not set its own this. The arrow function will not set its own this. Therefore, the arrow function can only receive what the this keyword is. The arrow function will receive what the this keyword is. Therefore, angry chef, right? Inside here, we know the this refers to angry chef, right? When I'm inside cook food, angry chef dot cook food. What is the this for angry chef, not inside angry chef? Who says it's the window? What is the this keyword for angry chef? What is the this keyword here? What is the this keyword here? The window. What is the this keyword here? Angry chef. Remember, the whole thing, the this keyword is the window. Inside here, it is angry chef. So when I run this, when I run angry chef.cookfood, it is going to be pulling what the this keyword was for angry chef, which is the window. And we know window.chefName should be, therefore, undefined is cooking. Okay, that was bad. Undefined is cooking chicken.
So arrow functions default to
No, that's very important. The arrow function will receive what the this keyword was. It is passed in. It will make more sense as you get more practice, but I need you to understand the arrow function will receive what the this keyword is. Question?
So the arrow function does not create an execution context,
Its own execution context. It doesn't create the this execution context. Yeah.
but it does have an execution.
Yeah, I mean, like it'll run its function. Okay, so let's move on unless there's a question.
I was just wondering, like, if it was like one function deeper, then would it be like it would work?
If that is correct, if it is one function deeper, it will receive this keyword, which is what you think it is. Yeah.
So kind of if it's a narrow function, it points to like the parent surrounding the function. So like the outer function. So for the angry chef, the outer function is the angry chef, or for the outer function for food item in angry chef, the outer function is angry chef. So the function around it is the window. So we're pointing to like 2 levels out.
The context execution is the window. Yes. It doesn't point 2 levels out. Remember, angry chef is the context of execution.
So this in an arrow function
Will receive.
it goes out and looks for something else, and
Yes.
if it's nothing, then it defaults to window.
It doesn't default to window. It literally will be the window because that's what it was.
Okay.
It reverts to the default on.
It will receive what it was.
I'm reading that off of VLab from Arrow.
I don't know.
It's kind of, it's like default.
Yeah.
Default is not the word. However, the window is the default for this in the global context execution. The window is the default for this in the global context execution. Are these words starting to make more sense? Yeah, it's weird though, right? Because you never thought you'd be like talking like this. All right? Yeah. All right. Let's get dicier. Let's get dicier, and then we have to move on to object-oriented programming, object, and inheritance. All right, cool. So I will actually leave this up so we have it. What I want to do is I want to do an example where I write the function keyword, and I will explain to you why bind was actually important. So let's not actually invoke it. Cool. So I have a dog named Winfield. If you haven't guessed, this is not my dog. This is Andrew's dog. Cute, adorable thing. Look at it eat that cabbage. All right. Cool. It has fave snacks, which is an array. It has eat snacks, which is a function that does this dot fave snacks. Cool. Remember, inside dog, what is this?
Dog.
Dog. So this dot fave snacks should in fact be
This array.
an array. Questions on that? No, because of rule number 1 of how we understand this. Now, for each takes what?
They call that.
A callback. It takes a callback. This is a baseless function because the way the callback executes is I have a function that invokes another function. That's what a callback is, right? A function that will invoke another function. This other function has no context of this. It is a baseless function. It is an anonymous function that I literally defined right there in line. It is not actually attached to anything. Who feels comfortable with that sentence? That anonymous function, the callback, is not really attached to anything. Here's what I mean. I can have, if I wanted to, right, a function that's just called callback completely baseless, no friends, super sad, right? It takes no arguments, unfortunately, and it returns nothing, trash. Cool. I can do this, well, kind of, not really. Let me put cat, ugh, just gross. Great. And instead, I can pass in a callback that is completely baseless, has no friend, superset. Do you understand that what I mean by the anonymous function inside is actually baseless? It's not really attached to it. It looks like it is because I wrote it in line as I defined it, but really it's a callback.
So you have to find it.
We're going to get there, yes. So far, so good. Therefore, just looking at this trash, we know that this is a baseless function. We talked about baseless functions. What is this keyword for a baseless function?
Window.
Who says window? Besides the very confident and correct people over here. Great. Therefore, dog.eatSnacks is a function that can be invoked. What the? What the? What is dog? Yeah. Dot eat snacks is a function. What the son of? What do you mean undefined? No, I don't need to pass anything in. I'm invoking this function here.
Is this a console?
No, it should just console log.
Double banana?
No, I shouldn't. Something went horribly wrong here. Yo, what the? Yeah, my code is fine.
That was great.
I'm confused myself. Hold on.
Well, you have to put walk again.
No, I shouldn't have to invoke it again.
Like inside the
I shouldn't have to invoke it again. That would be crazy. It's not a function. Let's do this. Let's test our code. Powerful. Huh. It's in there. And what is this dot? What is this?
dog.
It's the dog, right? We talked about that. What is this dot fave snacks? An array. And this dot fave snacks for each will invoke this callback function. What the? This dot fave snacks dot for each. Something is bizarre. It's a function. And it takes in the snack, each one of these Bad Johnsons. And I'm just going to log. Oh, okay. Dang it. I'm going to log. Okay. Okay. I'm in JavaScript help. Hold on. Yeah. But
Last line.
embarrassing.
What?
Yeah. My console log's busted. Return. Yeah, I'm calling it with the arrow function. It should be reading undefined. I'm like losing my mind. Let's actually just rip it from the README. I could be doing something completely erroneous. Okay. Doesn't like that very much. It could be Chrome. It could be Chrome doing something bizarre. Let's do this.
REPL.
No, let's not go to REPL. Let's do what good JavaScript developers do. Yeah, let's run that bad boy in Internet Explorer. Definitely not. I have index.js. I have an HTML file that basically pulls in index.js, so I can just open index, oops, HTML. What is happening to my life right now? Oh, HTML. Woo! Oh man, bad day to be me. All right, cool. Okay. Yeah, this is fine. This is totally fine. Great. So what is dog? Dot eat regular eat fave snacks. What the son of a gooch?
You got it.
Dot bind dog, yeah, I know, but it should actually break.
This is exciting.
Yeah, you want to see the debug process? Yeah, cool. All right, let's do this. So I got rid of the bind. Dog dot regular eat fave snacks. What the? Come on. It won't like let me finish. You know what I mean? There it is. Oh,
Oh, that makes sense.
this is a new Chrome feature and not a bug. If it is not defined,
It will stop.
it will stop running in the console. It should run perfectly fine in your JavaScript though. Here, I'll show you. Should run perfectly fine. Here, ready? Dog dot regular eat fave snacks invoke, and I'm just going to. It won't work that way.
You got slapped on the dog.
I gotta slap it on the DOM. That is so gross. Dang, that is gross. Let's try just console logging it. That is so gross. There it is. Yeah, it doesn't. Chrome doesn't like that. Did you see that? That's freaking weird. Chrome doesn't like this very much. Yep, there it is. Okay, that is weird. Chrome as a dev tool will block it if it will not run. Interesting. That is a new feature. All right, cool. Reset. Let's dive into what just happened. Chrome, I never thought I'd say this, but Chrome got me good. Got me good. Wow, I might jump to Firefox. I was hurt. All right, so check this out. Let's get rid of this. I have a dog, and all I did was two different things. All right, I have an arrow version where I do this.fave snacks, which we all agree is the array, for each, and it takes in a snack as an argument. If you have one argument, I know Chris and Vera said this, you have one argument in a arrow function, you don't have to put in the parentheses. One and only one argument. If you have 0, you must put it. If you have 2, you must use it. The parentheses, cool, the bananas. If you have 1, like here, you can do it. So you do snack, and all it does is it logs. I can do the regular John, right? The function keyword. Yeah. And all I have to do, remember, the main difference is this. That's the only difference. I can console log, right? All right, let's do, this is the function keyword, comma, and then this is the arrow one. And I can do dog dot, I believe it was arrow eat snacks. Are there any questions on what I'm invoking and what I want to see? So, let's take a look. So this bottom one's the arrow, and this top one is the function keyword. Okay? Let's talk about what is happening. Let's do this so we can see all at the same time and be nice and happy. So, in the regular one, the function keyword will create its own this because it is a baseless function. We've talked about that, it being like basically just defined as is, it's anonymous, it's not really attached to anything. So the this must be the window. That's why when it does this.name, window defaults to .name as an empty string. I will see empty string is eating snack, empty string is eating snack, empty string is eating snack, as I can literally read it right here. In the arrow, however, as somebody talked about in terms of being one level deeper, I have arrow, eat snacks. This right here, over here right now, this is dog. When I create the arrow function inside, the arrow function will bind this. It will bind the this keyword. And I can prove it because if I literally go right here and I put bind, and what is the this keyword right here? Dog. So I can bind dog. And both should now work. So the phrase and terminology is the arrow function will bind this. It's because this is dog here. It will still work.
Wait, why?
What I can do, const person is equal to an object that has a name of it's me, Luigi Mario. All right. If I passed in person, what should this be now?
Well, why can you pass in this? Oh,
If I bind this, remember what this is right here. So the arrow functions bind this. Who feels comfortable about that sentence? The arrow function binds this. It's very difficult to get to this point and explain it, but the arrow function will bind this. That's what that means. And that's why bind was important to teach you.
Would it still bind it if you made the initial function an arrow function, like the regular snacks?
Say again, love? Say again, over?
So regular snacks, key points to a value of a function, that was an arrow function. It wouldn't bind.
You're saying if this was an arrow function, right? This would be window, and window.favesnacks is undefined, and then for each on undefined will break it.
Does it bind because it's a baseless function?
Does what bind because what? No, the arrow function will, the arrow function as it's different from the keyword function is that it will bind the this keyword. So in the earlier example, when we did Chef Gordon Ramsay, when I did this right here, at the bottom here, it literally ran .bind this. And this was the this for angry chef, which was the window. So window.chef name should be undefined.
So it just doesn't matter in the sense that it's part of the arrow.
The arrow function will always bind the this keyword. Now do you know why I was like, I'll get to this keyword later? It's very tricky. Give me an hour. All right. All right, cool. That's all I have for you on this keyword. We don't have the luxury. If you need to go to the bathroom or get some water, I'd do it now. All right, I'm going to move right on to object-oriented programming. I'm so excited, and I just can't hide it. I'm about to lose control, and I think I like it. That is on the recording, yeah. And no, I will not quit my day job. I'm well aware. Okay. All right, I'm literally not going to stop. Great. So, yeah, this is just a fun little thing, a game that I made. I'm just going to leave this alone. So here's what I want to talk about. Yes, please shut the door. Shut the door! Shut the door! Okay. So we covered this keyword pretty in depth. Now I need you to understand a little bit more about why this keyword is important, and ultimately, how does JavaScript do its inheritance? We know how Ruby does it, and we know how classical programming languages like C, Java will also do it the same way. And that's why it's called classical inheritance. It will literally absorb all of the attributes and methods from before. Let's actually answer this question because I never did. I was trying to move too fast. Ay, ay, ay. Ay, ay, ay. No me gusta. All right. Cool. The question is object.method, and then var method is assigned to object.method. Let us literally recreate something like that. Cool. I have, man, did I still have all of it? Yes. Cool. Dang it. Dog. Cool. I have dog. I have dog.method. Right? Sorry. Dog.arrow eat favorite snacks is a method. Dang it. I just want them both to be at the same place. There we go. Dog.arrow eat favorite snacks. That is object.method. Other questions on that? And then I have var method equals to object.method. Cool, let me do that. Let me just put literally var some method, right? Whatever name I want it to be is equal to dog.arrow eat favorite snacks. The reference to, I'm not invoking it here. I'm simply assigning some method to be arrow eat snacks. Actually, let's do arrow eat snacks. Cool. Therefore, what is some method? It's a function. Is some method triple equals to dog.arrow eat snacks? Yes. You saw me literally assign it earlier. So what is dog.arrow eat favorite snacks invoked? Ugh, running into this nonsense again. Chrome. I should. So what is, dang it. Great. This is actually kind of important. All right, just know that it should console log. Chrome has like some weird functionality and features that I shouldn't have updated Chrome. Either way. Some method, however, doesn't even run, but we've noticed that some method and dog.arrow eat favorite snacks, they're exactly the same. They are strictly equal to each other. So why does one actually run and the other one just break entirely?
How JavaScript parses and executes my code.
It is the context execution. Remember, when I do dog.arrow eat favorite snacks, dog.arrow eat favorite snacks is a function. The first thing inside this function says this. So when I do dog.arrow eat favorite snacks, what is this right here? Dog. If I did some method, I'm literally going to be invoking function this, which is the window, .fave snacks. The time of execution will change when and where and what this keyword is. So, these two snippets are different according to Dan Abramoff, which they are in fact different. Who feels comfortable knowing why they're different and what this keyword is and context execution? Cool. Congratulations, you understand JavaScript. Very good. Thanks, Dan. Noise. All right. Let's go into inheritance and the prototypical chain. Okay. Boop, boop, boop. All right. So this is what inheritance really is. I'm going to boil down. I got to move kind of fast. Inheritance is literally just the sharing of methods and attributes. That's all it is. Right? Like if I'm a person that inherits from like, I don't know. God damn, I'm bad at science. I'm a human that inherits from like, what is like animal? Right? That inherits from like, I don't know.
Primate.
Animal doesn't inherit from primate, does it?
Carbon-based life.
Yeah. Like life form, yeah, carbon-based life form, right? There are certain attributes and methods that I'm accessing from up that inheritance chain. So Ruby and JavaScript are a little bit different. I have to move very quickly. So here's the deal. We have a robot, right? And all it is it just has these attributes to it, right? Name, weight, and specialty. That's all it is. I can create another robot. How would I create robot number 4? Yeah, const robot 4 equals, that is terrible. It is tedious and error prone because of like typos. What if you wanted to make 10 robots? Do you want to command C, command V? You want to copy and paste them? You want to command shift D them? No, that's terrible. I know if I'm repeating a lot of code that there's probably a better way, TM. What I can do is something called a factory function. And that is, I take a function, and all it does is it accepts 3 arguments. For every single argument, I make another robot that take, this is the ES6 shorthand. Dang it. All right, don't let me down, Chrome. Not again. Come on, Chrome. Cool. So this right here is known as shorthand. This is what it's supposed to look like. Boop. Right? So here's just a quick shorthand, right? If the key and the value are exactly the same, you only need to write it once. If the key and the value are exactly the same, I only need to write it once. This is the key value shorthand in ES6. Cool?
Wait.
Oh, I think you said wait.
Sorry, I did.
You did? Oh, I'm losing it. All right, great. So basically, all I'm doing is making another robot with name, weight, and specialty, and then I return the robot. So this factory function, all I have to do is pass it in these 3 things, and then I can make another one. So like robot factory, I can pass in the name. You got a robot name?
Jack.
Jack. Oh my God. Here we go. Let me guess.
Please.
Should have gone. Should have known. Oh, you're right. Okay, great. That's the specialty. And how much does Jack weigh?
2.
Very good. 2. And there it is. Another robot. I can easily make another one that's a little heavier. You know, maybe Jack's been getting some gains. And those are just 4 different robots. So this robot factory allows me to produce robots very quickly.
Do they get unique IDs when you do this?
Say again?
Are they getting IDs with this?
No, but we can, and I'll get to that in a second. So this is great. However, what if I wanted some sort of functionality with this robot? Right? I think I have some Ruby in here. Oh yeah, give me that. It's just because it's what you know and love, right? Powerful. I have the initialize right here, which is very similar to this factory function. And then what I want to do is create this shared method called recharge batteries. How would I do that with this robot factory? God bless you. Not necessarily. What I can do is inside this, I can then just define, right, a function. Okay. Dang it. Chrome is just really not being my friend right now. Oh, thank God I wrote it here. All right. The foresight. Inside my robot, I have the name, weight, specialty. I can also add functionality. That way, every time I make a robot, it also has this recharge battery functionality. I remember why I did this now, because Chrome's just not being my friend. Cool. So what I have here is, all right, Dan, we're done with you today. We're done. All right, what I have here is I can do robot factory, PA Rivers, 4, and let's just do this. Const robo1 is this, the return value of that. So now I have robo1, and it's Jack. All right, does anyone else want to be a robot? All right, okay, we're done with that. All right, okay. We're done. All right. So we have robot 1 and robot 2. So far, so good. Now let's check out robo 1 and let's check out the recharge batteries functionality. Okay? Okay. Let's check robo 2 and we check that recharge battery functionality. Okay? They look the same. What's the next thing we should probably think about in terms of if they look exactly the same? Should we test that? Okay. Dot. What do you think? Does anyone know why they're false? Yes, while technically the this keyword points to something different, this is why they are different. When I created this object, I created it with the attributes of weight, name, and speciality. I also created the attribute with this function. Remember, functions are passed by reference, not by value. So when I made this robot, I made a new function, put it in a new piece of memory. When I made robot 2, I said name, weight, specialty. Also created a new function that points to a different place in memory. We can determine that this is very, very space inefficient. If they share the same functionality, why are they pointing to different functions that do exactly the same thing in different places in memory? Do you see the problem? So, would it make sense that if they share functionality, I have a separate object and that both of them can pull from that same object? So, let's do that. Wow, powerful. What I can do is use the power of prototypical inheritance. And here's what that means. If I simply pull out the recharge batteries, and I do this instead. So far so good on this. Ready? All right, Google. If I did this, and I declared a separate function, recharge batteries, I can do robo, let's do that. Let's make OPA Rivers again. And let's make the person I'm totally done with. Cool. If I did robo 1, does that person have a recharge batteries function? No, they don't. Cool. But I can assign it to simply be whatever this recharge batteries function is. So robo1.recharge batteries is in fact simply a function. Robo2, I can also assign it to be the same. So would it make sense that robo1 recharge batteries is strictly equal to robo2? And they're still the same. And they still, in fact, work. Oh, man. Chrome is really getting me today. This actually works. It does work. It's bizarre. Either way, that's the idea. I can, if I wanted to create shared functionality, extract it, and then assign key values to point to the same thing. So if I were to go to my favorite drawing application, I don't have a mouse this time, so forgiveness please. I have an object, all right? Object, oh man. This is literally me on the touchpad, all right? Just, you guys are mean.
That's a really straight line.
All right, you guys are mean, all right? And I got object number, you guys are,
Oh, nice.
this was not bad, this was not bad, right? I can, in fact, put different key values. This is a key, this is a key, this is a key, and this is value 1, value 2, just do it, right? Nike. And then I have a object with keys. These are keys inside the object, all right? This is not really what they look like. I need you to take a journey with me, right? And this is a value, and this is a value. What I should not be doing is creating a function here and creating a function here, because it takes up 2 pieces of memory. If I do, however, let's do that, because I'm nice. That's fine. If I, however, define a function here and take value 3 and point to it, power of reference, now I've created this one function one time, and I can have infinite number of objects all point to one function. Do they all have the shared functionality? Can they all do the same thing, which is what inheritance is? Yes. But now I'm not wasting space creating objects that have their own exact same function as everything else. This is known as prototypical inheritance. So this right here can be part of the prototype for these objects. That's the idea behind it. So I don't have time to go into object.create. So you can read this very extensive README. It's powerful. What we can do is check out the prototype of an object. So if I did robotfactory.prototype, it will tell me, all right, inside the constructor function what it points to. So if I did new robot factory as opposed to simply invoking robot factory, I can see the prototype. This gets really dicey, and this is what I mean by that. The prototype is literally just an object that holds all of the shared functionality. So let's take a look. I can console log an array. Yeah? Cool. Let's take a look at the array. The properties of it. Did I define any methods on this particular array? No, but inside the proto, I can do all of these things. Find, length, map, pop, push, reduce. That's how every single array has all the same array methods. And so if you look at array MDN, what do you see on the side on the left? That's what the prototype means. There is an object that the arrays point to that has all of this functionality. And that way, every time I make a new array, I'm not recreating find. I'm not wasting all that space. I'm referencing it. And so that's how JavaScript does its inheritance a little bit differently. Any questions on prototypical inheritance and just this amazing ++ visualization on how that works? Yeah, I know, it's great. Yeah, you really got an artist for an instructor. It's amazing. Prototypical inheritance.
Just out of curiosity, where are those functions where prototypical inheritance actually stored? Is it coming through JavaScript? Is it coming through
The language.
browser? Okay, so it's
The language, yeah. So we can add to the prototype. Do you remember monkey patching and just jumping right into a class string and just overriding the length method? You could do the same. Let's not do that though. In order to add something so that every single object can receive it, I literally do robot factory and I do .prototype and I add a new key to that prototype object. And I call it recharge batteries, and it's just going to be a function. And so if I wanted to take the array and I did array.prototype, then I added something new. Let's do that actually, that'll be fun. Ready? Array.prototype, and I put new functionality is actually equal to a string of nothing. Psych, got him, coach. If I did array, right, I made a brand new array, dot new functionality, it would exist. So I can do array.prototype. You want to make, like, let's, something real, like, I don't know. I really don't know. Right. Push-ups, right? And this could just be a function. Boop, 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 boop. And that will literally, I don't know, return. Can I return emojis? Heck yeah. Gains. Cool. So if I did a brand new array dot pushups, it's a function, and I can invoke it. That's exactly how like 1, 2, 3 dot map works. It's a function, right? But it obviously needs a callback. So you can get really crazy and just put real crazy, and that this is a function that receives a callback function. All right, now it's getting dicey. Dang it! Dang it! Chrome is a function that receives a callback, and then inside it will return the callback being invoked. And that's really how the .each, the .map, the .filter, that's how it's working, right? It's array.prototype.map is a function that receives a callback. That's it. So I have an array.home, and this receives a function, and all it does is it will return 7. Yeah, that's not sexy looking, but it's fine. Oops. Yeah, I'm missing that. I'm in JavaScript help. Cool. So Chrome will invoke this function, the callback, which just returns 7, which is why you see 7 here. So prototype.
So in Ruby, you could do array.methods, and that would show you all the methods. Is that what it was?
Yes.
What is it? So if you did array.prototype, it would show you all that as well?
Here's the thing, right? Remember, prototype goes on what is known as like the class-like object, the type of thing that it is. If I go into an individual instance, I have to check its __ proto. So this particular array can do all of these things.
Okay.
Right? And what I mean by that is literally, let's just say I have an array and it's a string of your boy. I can set its proto and add a new key to it. Only this one. The one ring to rule them all. Cool? That means if I make a brand new one, should I have access to, what did I name it? Only this one? Interesting. I'm hacking the prototype. Do not do this. You should not be using this right here.
Okay.
All right? This is designed to be written in a way that you cannot accidentally type it. Right? Yeah, if you overwrite something on the __ proto, and then your boss is like, oh, what happened? Why'd you do it? Like, just typo.
But you
I don't know.
can always check it if you were looking for it.
Yeah, you can, the proto literally is just checking to see what do I have on this prototype. Cool. And that's kind of it in a nutshell, but I want to talk about classes in the last like 5 minutes. Really, the main things is you have a class. This is the one thing, one for Ruby that I'm like actually like okay with saying, is constructor is initialize. Cool? So if you have questions on constructor, you really have questions on initialize. All right. And inside the class robot, I just define regular methods. This is look like a Ruby, right? Boom. Just bam, def. The thing about it is, remember, I do not put the keyword function. I just simply write the key name, tell it that it's a function, and then say what it does.
Is that because they kind of want, because it's a method more than it's a function?
This is a method. Here's why this is a method, right? And I want to talk about this. I want to talk about what the difference between a function and a method is. In Ruby, you've never heard the word function, really. You've always heard method. A method is a function that is being invoked on an object. A method is a function being invoked on an object. So for example, I'm defining this method recharge batteries because the only way to invoke the function recharge batteries has to be on the object robot. So you've also heard the term everything in Ruby is a. So you can't really have a function on its own, because if everything in Ruby is an object, in order to invoke a function on an object, it is in fact a method. Smart. Level up. Great. So yeah, this is how you define methods inside your class. And then it's important to note that because I'm defining methods here inside a class, if I use the this keyword, will it be A-okay? Yes, because I will always be doing this. I will always be invoking recharge batteries on the object. If I'm doing on the object, the this keyword becomes the instance of that object. So here I have Sparko. Oh, dang. Here I have Sparko, the Iron Giant, and Bender. And then if I invoke recharge batteries on 1, 2, and 3, it will take the this keyword properly, because it's taking the this keyword from robot 1, or it's taking the this keyword from robot 2 based on the invocation.
Is that actually invoking? Is that just what you call it within the class? Like if you make a recharge batteries with no bananas, would it be the same thing?
This is actually shorthand. This is shorthand for this. I could be. No, I have it right here. This is shorthand for this. The walk is a key that points to a function. So instead of doing that, you can go bloop, bloop. Nice. All right, if you want class variables, you can just drop the old static on there. This will allow any character class to be able, the character class itself, to be able to invoke that function. The character class itself to be able to invoke the class method. All right, so
That would be like a bind file situation, like in Ruby.
if you want to do it real janky, yeah, in the static method, you can have an array in here, let all equals to empty array, and then in this static method, every time the constructor is invoked, it would simply, yeah, shovel in that instance into the all array, and then this would just return all. This would just return all. Ugh. I don't know how some of you live with your indentations. It's wild. You just get better, that's all. Anyways, cool. So I did promise to talk about like IDs incrementing and like the power of like private variables. So let's do that. Please like read through this. It took a long time to write. So here we have let total robots made be 1. Remember, robot is a function that returns what? A class, which is essentially a function. And that has a constructor. So I can have robot 1 be new robot. And look, if I check its ID, it changes. Here's why. Look at this parentheses right here. Look at this parentheses right here. And what is this? It's immediately invoked, which makes total robots made a private variable. Because when I immediately invoke it, what does robot actually have stored in memory? A class Robert. Because it's invoked. Remember what it returns. This is being invoked immediately, and it will store the return value into robot. So, if robot is the stored return value of class, will I ever have access to this ever again? but does it exist inside robot? So when I in fact invoke the constructor by saying new, just like initialize, what's this? Total robots made plus plus.
That's janky.
No, this is correct. So whenever I make robot 1, 2, and 3, the ID goes up plus plus every time. And so now I have the ability to create a counter.
So you can't accidentally change your total robot's name as a result of the need to drive.
That is correct.
Why would you do this if you got it back that it has an ID?
This is sort of the idea of why JavaScript was able to be made into a backend. That's why Express exists. Yeah.
So everything we covered today is kind of a way of using JavaScript backend.
Say again?
So all this we covered today is kind of backend use of JavaScript.
Not at all, no. I'm just saying that it lends itself to be able to be written, JavaScript to be a backend. Typically, as I've mentioned several times, that JavaScript was developed to be just behavior and just front end. Because of what we've been able to do with JavaScript, we can create a backend. So the last thing I'll walk you away with, I know that you have Launch, is this. Right? We have babel.js.io. I've talked to you guys about it. All right. And so we have what backwards compiles. There's no such thing as like classes inside JavaScript. So if I have something like this, class, that's fine. This is what it actually becomes. Oh no, I'm in JavaScript hell. Is this it? This is what it looks like without the syntactical sugar.
Thanks for leaving us on that.
Yeah.
Pure. I like that.
Yeah. Basically, robot is a function. Don't worry about that, but it passes in the this keyword. It makes it. When it does it, it points to all the keys and the values of the robot. That's what really makes the method. I do not expect you to understand this right now, but what I want you to take away is that there's no such thing as class. It is like basically hacked together, but some of it you can read. So for example, constructor.prototype. So inside the constructor function, in the prototype, you're adding additional functionality, which makes sense because for the robot, for any time I have additional methods I want to add to the prototype of this robot. So that's what's happening under the hood. So someone at my level will read this not easily and be like, oh, I get it. And you can too. It will take a long time, and there's a lot of magical Googling happening. But really, everything I explained in lecture, basically, this is what it's doing. All right, it is lunchtime. What are your questions for object-oriented JavaScript, inheritance, the prototype chain, how it's different from classical inheritance? It's a lot. Cool. Find me after lunch, yeah? Thanks.